jump in? Yeah. Good. So we're going to have just a quick look at both smoke hazard management and then also exit signage. So I won't go through the performance requirements for the smoke hazard management, just straight into the deemed to satisfy. So we go didn't write down the first bit. It's not atrium. So yeah, building must comply with B, C, D, and table E.2.2a as applicable to class 2 to 9 buildings, such that each separate part complies with relevant provisions classification, and E.2.2b as class 6 and 9 buildings. So that's not us. So we've got E.2.2a. So head down to E.2.2a. And then I'm just going to scroll through this relatively quickly through the sections that don't require, well, we've covered fire isolated stairwells already, buildings more than 25 metres in height, not us, but there we go, class 5, 6, 7, 8 buildings. So 5, 6, 7, 8, 9 buildings, part of building must be provided with a zone pressurisation system between vertically separated fire compartments in accordance with AS 1668. I'm not expecting you to be designing those, and we don't have any requirements for doing any of the heating, ventilation and cooling system design, which that would be a part of. So we can skip past that. However, it is good to have a note on your fire isolated stairwells to say smoke control system in accordance with NCC table E.2.2a. So then going down, so yeah, we'll call it a zone pressurization system for your stairwells. Then for so that's moving on. C. So, the automatic fire detection and alarm system complying with AS 1670.1 and monitored in accordance with Clause 8 specification E.2.2. Sorry, that's large isolated buildings. 5, 6, 7, and 8. So buildings, there we are. Buildings not more than 25 metres in effective height. So that's us. Class 2 and 3 buildings, and class 4, we're not those. So then class 5, 6, 7, 8, and 9 buildings. An automatic smoke detection and alarm system complying with specification E.2.2a. So that's the bit that we need to go to. So we need to design an automatic smoke detection and alarm system in accordance with specification E.2.2a. So if we scroll down to that, because that link was not working. So specification E.2.2a, smoke detection and alarm systems. So type of system, that's for 2 and 4, class 3 buildings. 5, 6, 7, 8. So a smoke detection system complying with clause 4, that link works, click on that one. Smoke detection systems, all class 2 to 9 buildings, a smoke detection system must, subject to B and C, comply with AS 1670.1 and activate a building occupant warning system in accordance with clause 7. So then we go to AS 1670.1. What we're interested in for our smoke detection systems is where we go putting our smoke detectors. So we're looking at, so the main thing is we're looking at our locational requirements. We're not going to be designing the intercom system beyond that, but we're going to be, for doing our services layout there, we're going to want to show the location. So we work our way through down to, and note that in the NCC it said a smoke detection system. So there wasn't, so if I flick back to that, so there's not specific mention of any other detection system apart from smoke detection system. So the smoke detection system and any other detector seems suitable in accordance with may be installed provided that smoke detectors are installed elsewhere in the solar units in accordance with requirements for alarms. So smoke detection is our only requirement. So then we go down to, so we've got installation requirements. We can move on from that. Then we get to, we've got section 4 heat detectors, section 4 smoke and carbon monoxide, and section 6 flame detectors. Now you can get detectors which are a combination of all of these, and so you could mark on your plan, come up with some sort of symbol that represents that and go combined heat, smoke and flame detector. If we were to look at heat detector and flame detector locations, well, heat detector and smoke detector locations, they're basically the same requirements in terms of how far they can be from each other. So if you want to do combined systems, that's fine. If you want to just specify smoke detectors, that's also fine. So for specifying our smoke detector, we go to section 5, so starting on page 48. I've got to scroll that down. We get 51, 48, and it gets fairly simple. So we won't worry about this in here. Go straight to spacing between detectors for level surfaces, because that's what we're going. That's the type of system that's the ceiling system that we're going to be installing in this office. We don't have any bulkheads and protrusions. We're not arranged ceiling or anything like that. So it's just for level surfaces, because that applies to various different heights of those detectors for for when you've got articulation happening in ceilings. But we can go straight to this one. So for level surfaces, detectors shall be arranged so that the distance from any point on the level surface of the protected area to the nearest detector does not exceed 7 meters. In addition to the distance between any detector and the nearest detector, it shall not exceed 10 meters. So for optical beam smoke detectors, distance between beams shall not exceed 14 meters and not more than 7 meters from a wall. Aspirated systems shall be so arranged that the sampling points have the same maximum spacing as that required for point type smoke detectors. So here, where detectors are installed in an area of less than 200 square meters, the detectors installed in a staggered grid shall meet the following. So that's not us. We're more than 200 square meters. So we have the thing that although transmitters, receivers and reflectors shall not be more than 3.5 meters from any end wall or smoke curtain. So if we're going for point type detectors, that's going to be fairly easy design. So arrange the distance from any point on the level surface of the protected area to the nearest detector does not exceed 7 meters. So you can get your the boundary of your room, offset that by 7 metres. That's going to be your first line of smoke detectors, and then um, from there on, in addition to the distance between any detector and the nearest detector, it shall not exceed 10 metres. So then that 7 metres, you can offset that by 10 metres and create your grid in that fashion. So it means you're not going to have many smoke detectors within your room, which is quite understandable. But that's the process by which you work out your absolute minimum requirements for those smoke detectors. Now, beyond that, there are requirements for the spacing of, or there's diagrammatic representation of the spacing of smoke detectors in both a horizontal and vertical sense. But just those stipulations in spacing between detectors for level surfaces gives us enough design information to determine that layout. So that's smoke detectors, and that's really all that you are required to do for that.
But 10 meters from here. Yeah, okay, that's it. Because what if I offset 7 from here, 7 from here,
there,
and
yeah.
yes.
Yeah, so what you can do in now, I can't think of what the dimensions are
Yeah.
of that building off the top of my head, but if you offset 7 metres, offset 7 metres, that's your first line of detectors. And then let's say in between those it was 15 metres, well then you just pick that midpoint of that line.
And if it is less than that,
Or if it's less,
if it's the minimum, is that
or
right?
if it's less than 10 metres between those two offset bits, well then that's all you need.
yeah,
Because you
if
got
it is not less than.
yeah. But then if it's 30 metres, well then you then you offset by 10, and as long as that middle section is also 10 or less, then you're fine.
Right, so we can offset more from here.
Yeah. So offset from So start with that 7 metre offset from your walls, and then work out your locations based at maximum 10 metres from there. So to go to exit signage is part E4. So we're down. Where are we? It's into F already.
About the small detectives, do we need to design for the corridor?
Yes.
Okay.
Yep. So that's also within your room.
I mean, just like outside the office in the is the corridor.
Yes. Yep. Yep. Excuse me. Let's get to E4. G'day,
Hello.
Maren. How you doing?
Is your class? What time does your class finish?
Oh, sorry. I'll stop this recording.
Oh, sorry.
Pause it. Right. Get to E4. I'm just going to go straight up to the contents and then type in the page number. E4 221. Right. So visibility in an emergency exit, signs and warning systems. So, we'll read the performance requirements of this so we know this is what has to happen. So to facilitate safe evacuation in an emergency, a building must be provided with a system that ensures a level of visibility sufficient to enable exits, paths of travel to exits, and any obstacles along the path of travel to an exit to be identified, and activates instantaneously upon the failure of an artificial lighting system to the degree necessary, appropriate to functional use of the building and floor area of the building and the distance of travel to an exit. So we've got to have lighting systems that enable that. And then identification of exits. To facilitate evacuation, suitable signs or other means of identification must, to the degree necessary, be provided to identify the location of exits and guide occupants to exits, and be clearly visible to occupants, and operate in the event of a power failure of the main lighting system for sufficient time for occupants to safely evacuate. So yes, we need to have autonomous power supply, so when power goes out. But the main points here are to identify the location of exits. So that should be a big part of your thinking as to where those exit signs go. Guide occupants to exits and be clearly visible to occupants. So you've got to think about locations in your floor for your exit signage that meet those requirements. So then for the exit signs for deemed to satisfy, um, go to we've got so um, E E4.4 for design and operation of emergency lighting. Every required emergency lighting system must comply with AS/NZS 2293.1. Now, what I'm expecting in this project is that if we were to go have a look at AS/NZS 2293.1, we would see that the design of that exit lighting, so that the emergency lighting is actually really quite complex. I'm not expecting you to design any of that emergency lighting because it's about the transmission of that light from those sources in accordance with the height of the ceilings, etc. So I'm expecting a note to the effect of emergency lighting systems must be provided compliant with that. Beyond that, I'm not expecting you to determine location and luminance and spacing of these lights because there's no simple design information there for that. That's more of a complex consultant requirement. But exit signs. So an exit sign must be clearly visible to persons approaching the exit and must be installed on, above or adjacent to each door providing direct egress from a story to enclosed stairway, etc, etc, etc. So these are our exits. So we need to have an exit sign above each of those exit points. If we think about our level 1 on that floor, we've got exit points at either end. We need to have exit signage above those. And then a door from an enclosed stairway, passageway, or ramp at every level of discharge to a road or open space and horizontal exit. So once we're in that fire isolated stairwell, then the door that's exiting to that safe space, that needs to be identified as that exit point as well. But you're not doing that floor plan, you're not having to show that on your. So a door serving as or forming part of a required exit is still required to be provided with emergency lighting in accordance with E4.2. So that's our identification of exits, but we've got to get the people to those exits before that. So they'll need direction signs. So if an exit is not readily apparent to persons occupying or visiting the building, then exit signs must be installed in appropriate positions in corridors, hallways, lobbies, and the like, indicating the direction to a required exit. So that's your next only other requirement is that you have to think about occupants within that office space from where they're sitting. If there were an emergency, can they look up and they go, right, I need to go that way or that way. So it's about thinking about your exit signage to make it clear that from where I'm sitting, the exit is in this direction, and then I have an option of that one or that one to go to my exit. So it's not about so much having signage within that space, but signage within the path of travel to the exit that's going to be visible by people within that office space. So if you can have exit signage within that corridor that's going to be visible by everybody within that space, then that I think is the best design. So that's our only requirement. It's more, that exit signage. It's more about performance. So rather than being prescriptive about this is the spacing of them or etc., has readily apparent to persons occupying or visiting the building. Exit signs must be installed in appropriate positions in corridors, hallways, lobbies, and the like, indicating the direction to a required exit. So, and then then the rest. Oh, that's right. Yeah, I did put this one down to talk about as well, but in short, it's not going to apply to us. So, an emergency warning and intercom system complying where applicable. 1670.4 must be installed in a building with an effective height of more than 25 metres. That's not us. In a Class 3 building, that's not us. Class 3 building, it's not us. Class 9A building is not us. And Class 9B building is not us. So we don't need to have that emergency warning and intercom system with ours. So we just need to have our smoke detectors, our exit signage, and that's it. So it's more about thinking about that clear location for that exit signage.